For today's notes, we are going to be looking at how exponential graphs are shifted based on different numbers that change. So the first thing is that this is an activity that we're doing in class. Realistically speaking, you can do the same discovery at home. You can, our goal is going to be to determine what each letter, the A, B, and C, does to change an exponential graph. But you're going to be going into Desmos and graphing each of these different graphs and creating sort of just the general idea of what it looks like and seeing how some things change. So I'm not going to do every single graph. If you are at home and you are missing today's notes at school, then you'll need to open up Desmos as well on your own and take a look at what those graphs look like and see what changes you see as well. So if we look at this first equation, y equals 2x. So again, I'm just opening up Desmos. You just can't see my computer being open and I'm graphing that. And when I look at what I see on Desmos, I see a graph that in general looks like this. Now, is that a perfect rendition of what it looks like? No, but in general, that's the general idea. Okay, so when I look at the next one, it asks me to graph y equals 2x plus 4. So again, on my computer, I have graphed y equals 2x plus 4. And when I look at this, I see a graph that looks like this. Okay, so your job is going to be to graph these two in Desmos. Okay, and then to explain how adding or subtracting a number here at the end of the equation is changing this graph. Okay, in some way, shape, or form, hopefully we are noticing that that graph is making a shift up or down, depending on the number. But again, that can sort of be in your own words, depending on what you see as you look through all of those different graphs. Okay, and our next one, again, we start off with y equals 2x, which we already graphed for our first one above, so we knew that it was something like this, because we already graphed it. Okay, now it's going to ask us to graph y equals 3x. Now my suggestion to you would be to graph it on top of the same one, so don't delete out the old graph and graph in the new one, and maybe see how that graph looks different. But when we graph it, we are going to get something that looks like this. It's going to be very similar, oh, mine got a little bit excited about turning up there, right? Okay, but it's okay, just the general idea. Okay, and as you continue to do these different ones, again, I'm just graphing over here on my computer, take a look at how those different graphs look and what happens. So as that base gets larger, what is happening to the graph? Okay, I'm not going to fill that in for you. You'll have to decide. Okay, then our next one that we're looking at is y equals 1/2 to the x power. Okay, and we're going to just make a general graph of what that looks like. Again, I graphed it in Desmos, and now I'm just copying over the general idea. You'll do y equals 1/5 x. Okay, and again, as the base gets smaller, or as it's getting closer to 0, what's happening to that graph? You want to make a decision there. Okay, so when we go into our next set, y equals 3 to the x. So if we get graph y equals 3 to the x, we already did that once before, so I know it looks like my y 2 to the x, but just slightly steeper. Now I'm going to do y to the negative 3x. Okay, and when we graph that, we get something that looks like this. So you will continue on with doing the same thing with this graph here, and then making a decision about how adding a negative in front changes the graph. Okay, then we're going to look at something like y equals 4, 3 to the x. Okay, for this graph, it looks like this. Now we're going to put a -2 in front. And we get this. Okay, so you'll finish that and you'll answer that. So once we go through and we notice all of those shifts, we should be able to give some very specific terminology to how each of these numbers are playing some role on the graph. So the first thing that we should have noticed is this C number on the end. Okay, that was changing how much the graph was shifted up or down. This actually gets a very fancy word. It's kind of a bizarre word, but we call it an asymptote, which I would not have expected you to just know that word. Okay, that asymptote is really changing. It's creating the line the graph can't cross. So it's either shifting that graph, if we're adding a value, if it's positive, it's moving it up. And if we're subtracting a value, it's moving it down. Okay, hopefully we noticed with our B values, so when we changed the value that was in front, if it was bigger, we started getting steeper, but still going uphill. If it was smaller, we started going downhill. So that B value, okay, if that B is greater than 1, it gets steeper, and it's going uphill in an increasing fashion like this. If it's less than 1, so 1/2, 1/3, whatever, okay, that it can still get steeper. We should have noticed as we change different values here at steepness, but now it's decreasing. And it's going this direction. Now, we didn't really look at one like this, but we could talk about the idea of that B value being negative. But if B is negative, we end up not getting a graph. So in the classroom, we took a look at how when we have a negative B value, what that does. But B can't be negative. Okay, now we don't want to confuse that with our A value, because our A value, right, this might look like our B value is negative, but this is really not in the parentheses with the 3. So this is really like a -1 times 3 to the x. So that's really our A value. And our A value is flipping it around that x-axis. Okay, so if that A value is positive, if that A value is greater than 0, right? It's above the, it's opening upwards above the x. It's above, I guess it's going this way. It's the 2 that we saw below, or it's going this way, depending on what that B value is. If A is less than 0, which means A is negative, right? It has that sort of downward shape to it, which means it's either going this way or this way. So once we know that information, we can then predict what a graph would look like. So we know that this is our asymptote, which means it's telling us it's shifted up 4. So we need a graph that can't cross that line. We know that our B value is 2, which is greater than 1. So we know we're going to have this motion, but on the underneath side because A is negative. So we got to flip that around the axis, and our graph is really going to be somewhere like this. Okay, we can tell all of that general info just from identifying our A, B, and C. So your job is to make sure you're finishing the rest of graphs in here, you're getting the actual graphs and making predictions on this last one.